Up next, we have Raghavendra Sirigeri, the founder of QuestionDev. Raghavendra will be presenting on the art of container image reduction, tools, techniques, and best practices. He will cover strategies for optimizing container images for efficient AI or ML deployments. Now, let's welcome Raghavendra Sirigeri to the stage.
Thank you. Yeah. So, this is going to be a very interesting session. It will be very interactive. How many of you have written Docker files here? Awesome, awesome. So you're going to enjoy this. And okay, cool. So how many of you face problems with big container images? Okay, cool. So you're in the right session. Cool. So to understand, how we can reduce Docker images, right? So we have to get a very good understanding of how overlay file systems work. Okay. So our agenda, we're going to do overlay file systems. We're going to understand how Docker images are layered. We're going to understand how we can optimize for build times, how we can use some tools like Docker Dive for image analysis. We'll also look at a very important technique that everyone in this room should really know, multi-stage builds. Then we're going to talk about line buddies, right? And then we're going to talk about another tool called Docker Squash, which will help you in squashing your Docker image layers. Okay. So let's look at overlay file systems, right? So overlay file systems basically comprise of 3 layers. It's a lower layer, an upper layer, and a overlay layer. Okay, so here a layer refers to a directory or a set of directories. So very simple. So for example, let's say my lower directory had these 2 text files, ll1.txt, ll2.txt, ul1. The upper layer had ul1.txt, ul2.txt, and let's say I defined my overlay layer in the merged directory. So what is going to happen once I mount my overlay file system is I see a union of all these files there. Okay, it's a very simple thing. So you will see the union of all these files in that layer. One important point is the lower layer is read-only. And any change that is done to a file from the lower layer will create a copy on write file of the modified one in the upper layer. So we'll look at this with a practical example as well. Okay. So this is what it is. I'll just show you a quick demo of this. Yeah. So now let's say I have this setup where I have a lower directory, very simple directory. It has 3 files. I have an upper directory, 3 files. Here note that dup.txt, both the files are named the same in both the directories. Let me go ahead and create the overlay mount directory for this. So first I create the merge directory and the work directory. A work directory is basically used for the intermediate processing to create the overlay mount. But finally we will see all the union of the files residing in the merge directory. So this is the most important command that we will use to create this whole overlay file system. And if we look at all the mount points, we will also see that one of the mount points is the one that we just created. So now the overlay file system has been created, and let's look at the contents of this merge directory. So do you now see that the merge directory has a union of all the files? Right? Everyone's able to see this? Okay, awesome. So now just see what's going to happen. I'm going to, you see that when I look at what is there in the dup.txt of this merge directory, I see the file that is coming only from the upper directory and not from the lower directory. So when there is a file name conflict, it will always pick it up from the upper directory. So this is one thumb rule that you should always keep in mind. Now let's do something fun, right? So I'll go to ll1.txt, and let me edit the file in this merge directory, right? Let me edit this file in the merge directory. I'll say appending a new line. So ideally, you would expect that ll1.txt, you should see that the file in the lower layer should have changed, right? Right? You would have to see that, right? But just see what happens now. But see what's happening. A copy of that file is being created in the upper directory here. Can anyone tell me why? Yes. So the lower layer is read-only. So the lower layer is read-only, as I told you before, and that's why a copy of the changes that you made in the merge directory is being added in the upper directory. Okay? Yeah. So that's what it is, and we look at one more important thing. Let's look at what happens if I remove it. So I'm in the merge directory. I'm removing a file called ll2.txt. Okay? So what should happen? Should it get deleted in the lower layer? Anyone? What should happen? Can anyone tell me? Sorry? Huh? Yeah, so what will happen in the upper layer? But it was not there in the upper layer. This is only there in the lower layer. So, good. So, now that you guys are wanting to know what is going to happen, let me show this to you. Let me look at what is there in the upper layer. So, you see here, in the upper layer, there is a whiteout file. This is called a character file. This shows that it's a deleted file. Right? So what is happening is, in merge directory, you don't see this ll2.txt, but in the upper, that's because in upper directory, there is a file called ll2.txt, which is a special character device file or a whiteout file. That shows that it's a deleted file. So that's why you're not seeing it in the merge directory. But however, if you see in the lower directory, it's still there. So this is very important. So when you delete something in the lower layer from the merged directory, a lower layer file, a whiteout file is created in the upper directory, and which shows that it's a deleted file. Okay? So hope everyone is clear with this. Okay, awesome. So let me quickly move on to the next one. And this is a very nice table of what's going to happen when new files are added or deleted or changed to the respective layer. So you can always, you can take a picture of this, and this is very helpful for everyone. Right? So let me go to the next slide. This is a Docker file. Everyone understands this? Right? So what is happening in a Docker file when you build a Docker image from a Docker file is an intermediate layer is being created for every new line in the Docker file. Okay? So that's what this is showing. So each intermediate layer has its own overlay file system. So each image that you see is its own overlay file system that is chained together to give you the final image. And we'll exactly see how that is happening. So if you look at this, the first command is from Alpine 3.6, and that is this base image that is here. What is happening in the next step is the Alpine file system that was there in the upper directory in the first layer is moving to the lower layer. Is going to move to the lower layer, and in the next image, and the upper layer will have the Python installation files as shown here. So here, if you see, it's installing Python, right? So the same one is happening here. And you can guess this again. In the third layer, you will see both the Alpine file system and the Python libraries are moving to the lower layer. Okay? And whatever you want to install in that command, that is the C++ libraries, will happen in that image. And finally, when you are running a hello world.py file that is shown here, what is happening is the lower layer will contain all the previous upper layers and the current command that is there that comes in the upper layer, and an overlay layer is created from all of this, and you get the final image. So this is how a Docker image is, the final Docker image is getting built with intermediate images, okay? And to look at this practically, you can run Docker image inspect on all the intermediate images. So if you run Docker image inspect on all the intermediate images, for the first one, you will see that there is no lower directory. You see that there's only a merge directory, upper directory, and a work directory, okay? Now pay attention to this upper directory, right? The upper directory here is coming as a lower directory, is coming into the lower directory here. And if you go to the next layer, both the previous upper layers are being listed in this lower directory. So this is how things are getting bubbled up, and these intermediate images are leading to a final image. Okay? Okay? Cool. So now is a small quiz for everyone. You see these two Docker files here, right? You can also scan the QR and vote for which one do you think is more efficient. Did everyone get a chance to vote? So let's see the responses coming in. Okay, so 6 people think, 7 people think A is correct, 6 people think B is correct. Okay, any more votes? Okay, both are same, 9 and 6, 10 and 6. Okay, interesting. So the small hint, think in terms of subsequent build times when source code changes. So here what is happening, which is the file that you are constantly changing? Server.js, because you're coding continuously and changing code there, right? Right? So what happens, these layers are all cached. Those layers are all cached, right? So that's why you would want something that you change very frequently to be at the end, correct? Something that's not changing too frequently should be earlier, right? So that you don't invalidate that previous cache and keep building again and again. So in terms of build time, if you look at what is best, it is A. As most of you have voted, it is A. Okay? Everyone understood this? Okay, awesome. So let's go to another. Yeah, so the main reason is these layers are cached as no changes are done here and can be easily retrieved in subsequent builds. So let's go to the next quiz. You can also again vote here. Are you guys able to make out what the difference is between these two Docker files? So the main difference is the run apt-get update and apt-get install SQLite 3 is in two different lines. Here, they're all in the same line. So let's see what the results look like. Okay. Okay, so we have a clear winner here. Okay. Okay. So can anyone tell me why? Can anyone tell me why B is better than A or A is better than B? Anyone? Anyone? Like quickly. Okay. Okay. So, okay, fine. So that is one thing. Okay, but what if I use, okay, that is one reason, but not the main reason. Because the incremental benefit from that is not as much as the other core reason, which is, let's say apt-get update. The first two are always cached. Here you see there are new packages being added here. So in the above step, when I add another package there, my apt-get update will have all the repository lists which are already cached, which may be old. Right? Which may be outdated. If I put both of them in the same line, if I add any new package, then even apt-get update will also run, because this cache will get invalidated, and apt-get update will again run, which means I'll get the latest package lists, which means all my packages are up to date. Did everyone understand this? So if a new package has to be installed in this cache layer, then apt-get update will contain the old package cache, and the newly installed package will be outdated. So in this scenario, B is the right one. Yeah, so this is something that we already spoke about. So let's look at another scenario of actually reducing Docker image sizes. If you see this simple Docker file results in an image of 1.3 GB. And you know which layer is eating up most of the space? Can anyone guess? Huh? Which one? Yes, so the base image layer, so that node 22, that itself I think is more than 1.2 GB. Okay, so that's why you see that this whole Docker image that this results in is 1.3 GB. Any other reasons maybe? So there may be sometimes in your, if you're working with Node.js or maybe other languages as well, there are only dependencies that you need as a developer, like for development. And those are these dev dependencies. Sometimes you've got to check whether these dev dependencies are also included in your Docker image and bloating up your image. So it's always good to, in your Docker file, only build a production, version, a prod, build, and then include it. Because some of these dev dependencies here can also bloat up your image. Okay? So these are not required during runtime. Okay? I'm going to talk about a tool called Dive. So how many of you have used Dive? Anyone has used Dive? Okay, awesome. So Dive is basically helps you navigate a Docker image layer by layer and see how the file has changed, how the file system has changed with each and every Docker, Docker file instruction. So here, if you see, the first few layers is the Node 22 base image layer, and it's more than 1 GB. And you see on the right side is a file system. As you keep going to the next line in this Docker file, you'll see how the file system has changed. And you know what this helps you do is get an incremental assessment of how your file system is changing, and also any stray files or stray folders that you're adding with every instruction. You can actually spot that and say, oh, I need to optimize this command and then change it. So you can make a note of this. It's called Dive. It's very helpful. Everyone should do this image analysis using Dive. Let's go back to, so let's look at this other concept called multi-stage builds. Okay? So here what is happening in this Docker file is basically, it is one Docker file, but it's split into two parts. What I'm going to do is, the first part, I'm going to only do the build stage part, right? So basically, in the first part, I use the Node 22 image as a builder image, and then do all the installations and everything. And then in the second part, I'm going to copy all the installed, packages, and then run it. Okay? When I do something like this, I get a huge reduction in image size. It goes from 1.2 GB to less than 300 MB. Can anyone tell me what is the core reason why this is happening? Sorry? Package, so but I'm moving the packages here, right? See, I've installed the packages there, but I'm moving it here. Sorry? Yes, he got it, right? So the base image. If you see here, in runtime, I need only the slim version of Node. I don't need the full Node 22. See, in runtime, I need slim version, it's enough, because everything is compiled. Everything is compiled, everything is built. And that's why this slim image is less than 200 MB or less than 250 MB, right? So that is the main reason why this is reducing. This image is reducing in size, because the packages are still remaining the same. So the main premise is, in build stage, you need a different Docker image. In runtime stage, you need a different Docker image, which is much smaller. And we will go one step further and look at something called as distroless images. So this is something that is also being used and being used at Google and some other man companies, where you look at the distroless image doesn't have a bash, it doesn't have many other things that a full-fledged Linux system has, right? So with that, you can even cut down your image size further. So here you see this GCR IO distroless Node.js 20 Debian 12. It's a very small image. So the more smaller you can make this image, the more the lesser the total image size will be. So you can see that it's come to 150 MB now. So can you imagine moving from 1.2 GB to 150 MB and what savings of costs and other memory and other things your organizations can benefit with such optimization techniques? Right, so this is what a distroless image is. It contains only the application runtime dependencies, does not include package managers, doesn't have a shell, doesn't have other Linux utilities, because they are meant to be run in production, right? And they're more secure inherently because the attack surface is reducing. Let's say when someone got their hands into this container, the attack surface is much lesser. I mean, there's no shell itself, right? So it becomes much more difficult. Okay, so this is probably the last part, one of the last parts of this whole session, where so this is my personal experience, right? So I installed my AWS CLI to a simple Docker image. The last part is where I install this AWS CLI, okay? This results in an image size of 777 MB, okay? Once I install the AWS CLI. Can anyone tell me how I can make this more efficient? Can I make this image smaller? How? Sorry? And how do I add the stage? Yeah, but that optimization already happened, no? Here. Okay, and move only the AWS part. Yeah, so that's a good point. So that's what we can do. Can I also do this? Can I do this? Can I add this line? Will the Docker image size reduce now? Yeah? How many of you say yes? Okay, but will it reduce drastically? Okay, forget about the packages. I'm saying, can I remove can I remove the AWS source installation package by running this? Yes, right? It will work, right? Everyone says it will work? Image size will still be 777 MB. Has anyone tried this? I think you should go today and try in a Docker file, install something, next line, put rm-rf and remove that whole folder and see the Docker image size. You will be astonished to see that it is still the same. Can anyone tell me why that is? Yes. So what is happening? It's the classic characteristics of the overlay file system. When you're deleting something, we saw that it never gets deleted in the lower layer, if you remember in the first part of the session, right? So it is creating a whiteout file in the upper layer, but it is never getting deleted in the lower layer. That means your image size is still remaining the same, right? So how do I rectify this? Can anyone tell me how I can rectify this? Yes, combine. So combine everything. So you combine this whole thing in one line. So this whole thing will get executed once, and as soon as it installs, immediately it will remove whatever is the source zip file. And now you will see that the image size is reducing from 777 to 506. Right? So just one more minute. So since there's no time, I'd like you guys to also explore this tool called Docker Squash. It helps you squash multiple layers of a Docker file into one, or you can choose how many layers you want to squash. Okay? And this is a very important tool, and you can explore this. Let me go fast. Some more tools that are worth exploring is these 3 open source tools. So you can make a note of this. And if you need to try out whatever has been told today, you can just scan this. You will have a ready environment for you to try out everything on Questo-Dev, which is my platform. And you can follow this whole tutorial and do it step by step. And if you need the PPT or any other resources, you can just connect with me on LinkedIn. And please love to get the feedback on this session. Yeah. Oh, sorry. So the tutorial can be tried out on a desktop or a laptop. It's a very bad experience on mobile. Yeah. Cool. Thank you. Thank you, everyone. Hope you guys liked the session.
Thank you so much, sir, for the highly interactive session. Now let's welcome Prasad Krishnan to hand over a token of gratitude. He is the DevOps Day champion and the core member of the team. Let's welcome him to hand over a token of gratitude.